that.
Okay, well, thank you. Let's try. So next slide.
Next slide. I will do. Okay. Okay, working.
Yeah, one more click, two more clicks. So I just said that in 1971, Fermilab has detected the neutrinos. And please click two more. Yeah, next one, yeah. Also in 1971, KK was established, and KK is indeed celebrating their 50th anniversary next month. Next slide. A Korean proverb states that in 10 years, even rivers and mountains change. One click. To me, this is a metaphor of the history of Hadron Colliders in the last 50 years from the ISR to LSC. Going next. So in US, now Hadron Colliders, around 1980, there were two colliders were under construction, Isabel 400 GeV proton-proton collider and Tevatron 2 TeV proton anti-proton collider. In 1983, Isabel got canceled, and Tevatron saw first collision in 1985. The SSC, the 40 TeV proton-proton collider, got canceled in 1993. As a result, Tevatron has ran much longer than originally planned. With its the end of the operation in 2011, US now has only one collider, that's a RIC, heavy ion collider. This RIC will be transformed into an electron ion collider in a few years. EIC will unlock the secrets of the glue that binds the building blocks of visible matter in the universe. Next slide. Just a few the highlights of RIC science achievements, including observation of strong elliptic flow in gold-to-gold collisions, observation of jet quenching in gold-to-gold collisions, and also a new state of hot and dense matter out of quarks and gluons, signature of a critical point, and discoveries of matter and antimatter production from photon collisions and polarization-dependent light bending in a vacuum. Next, please. So now moving to proton-proton colliders and proton anti-colliders. These are, of course, to reach the highest energies possible. Now, certainly it reminds me of Fermi's vision. He was an American Physical Society APS president in 1953. As a retiring president, he gave a speech entitled, "What Can We Learn with the High Energy Accelerators?" And he stated that the only way to access new physics is through the development of higher and higher energy accelerators. On right, you see his penciled note while preparing this speech, and the bottom have two beam collisions. Next slide, please. So the left plot shows the cost and energy in log scale as a function of year from 1930 to 60. You'll see, first of all, the growth is exponential both in cost and energy. So Fermi extrapolated using the lines, trying to see what's the highest energy or ultimate collider, that globotron that circles the globe at the equator. And about 40, of course, kilometers circumference. It'll reach around 1994 based on his escalation and costs about $170 billion then dollars and $1 trillion current dollars. Next slide, please. So in reality, you see that, in fact, we reached that energy around 1990, but dramatically smaller and dramatically cheaper. And this is all thanks to science and technology breakthroughs, global and open exchanges in science and technology, and collaboration and healthy competition. Next slide. So here are the elementary particles discovered by modern accelerators. Certainly Hadron Colliders have the highest energy possible. We're able to discover the heaviest elementary particles such as a top quark, Higgs boson, W boson, and Z boson. Next slide, please. Of course, collision energy is not the whole story, and luminosity is very crucial as well. Right plot shows tevatron luminosity increase in log scale as a function of time. There are novel ideas and implementations such as electron cooling played a very important roles, but also there are many small 5% level of the steps made this remarkable success in luminosity. This is due to a better understanding of beam physics and accelerator technologies. Next slide. Here I'm showing all the colliders energy and luminosity as a function of time. Remarkable progress has made in the last 5 decades. More than 3 orders of magnitude increase in energy, more than 4 orders of magnitude increase in luminosity. Many jumps through science and technology breakthroughs. And I also want to point again that each generation of accelerators has built on previous generations' experience and discoveries. Of course, this is not just accelerators. This is true for detectors and computing and analysis techniques as well. Next, please. Back to tevatron. This is rich physics outcomes beyond the top discovery in 1995. Precision measurements and rare processes, including W and top precise measurements and B sub oscillation, etc. These have been believed not to be accessible at a Hadron Collider. We would like to thank the European Physical Society, who gave CDF and D0 the 2019 High Energy and Particle Physics Prize for the discovery of top quark and the detailed measurement of its properties. Next, please. Tevatron's impacts are much broader than science. We have educated about 1,000 PhD students. And superconducting magnets in 1993, the late Robert Marsh of Teledyne Cheng, the then world's highest supplier of superconducting alloys, stated that every program in superconductivity that there is today owes itself in some measure to the fact that Fermi Lab built the tevatron and it worked. There are also large contributions to computing, PC farms running Linux, distributed computing grid and cloud, sophisticated analysis algorithms and techniques, including machine learning, and also the contributions to toward global collaboration. Tevatron certainly played important roles in establishing a genuine partnership between Asia, Europe, and the Americas. Next slide, please. So now I have the collection of messages from various groups whom I reached out. Let me start with D0 and CDF spokespeople. Altogether, we are 26 of us. There's many of those are shown in this photo. 2007 D0 CDF spokespersons get together during HIPAP meeting. 2008 D0 spokespeople photo there. Last year, 2011, this is during a tevatron shutdown event. This is a photo of a spokespeople there. Next, please. So I'll read some of the remarks from them. Hadron Colliders had an enormous impact on my career and indeed the trajectory of particle physics. The ingenuity of the collaborations to extract the signals allowed for results well beyond the initial program at all the colliders. This knowledge was passed from one collider to the next. Congratulations to CERN, in particular our accelerator colleagues. Next. The ISR taught us that there is a new physics in the high PT region of phase space. The SPP by S brought us the new tools of jets as primary objects and missing transverse energy for searching for new physics. The tevatron showed the unexpected power of vortex detectors and multiple trigger levels to tease out rare processes. The LSC solved the problem previously thought insurmountable of living with the multiple overlapping collisions and gave us simulations that could be trusted quantitatively. The theory, phenomenology, and experimental collider communities continuously pushed each other forward. We are all looking forward which kind of new elementary particle will be discovered at the Hilum LSC and or at FCC. Next. The story of Hadron Colliders is not just a story of technology and discovery. It is also a story about people and international collaboration. The thing that sticks with me the most is the ability to produce a first-rate science and consensus from collaborations of strong-willed individuals. Possibly the most important contribution to the future of the field is the number of young physicists who moved from one collider experiment to the next. Next, please. And one more click. So here are some of the CDF, the collaborators. This is international collaboration and diverse workforce. This really demonstrated that because we share knowledge and resources, because we have different training and culture, we have a much better science produced. Next slide, please. So I have also messages from our accelerator colleagues. Steve Holmes, we benefited greatly both from extended residencies of our scientists and engineers at CERN. He also pointed out the value of cooperative competition. Sergei Nagachev, the Tevatron antiproton team stood on the shoulders of giants such as Simon van der Meer, Dieter Mill, and other CERN colleagues. Hope to continue to play a role in collider accelerator physics wherever it might be. Next. There are 6 lab directors at Fermilab from the beginning to now. All of them have been associated with the Tevatron, starting with Bob Wilson, the first director. The R&D for superconducting magnets studied during his time. And now Nigel Lockyer time, the analysis of Tevatron data still going on very strongly. So here is a quote by Pierre Odone, who was a director between 2005 to 13. First, happy 50th anniversary or birthday to CERN. Colliders at CERN. What a fantastic 50 years, developing ever more powerful machines, making the discoveries that underpin the standard model in an atmosphere of a competition, but above all, strong collaboration and a common purpose. Next. Also, I have a message from the DOE Office of High Energy Physics, impressive science results, which is a testament to the collaborative international research program that is fostered at CERN. Advances at CERN have also enabled particle colliders hosted in the US, those at Fermilab, Brookhaven, SLAC, and Jefferson Lab. Looks forward to 50 plus more years of partnership with the CERN. Next. Here's a message from the NSF Physics Division. The international multicultural environment provided by CERN has produced innovations and technology advances, as well as new fundamental discoveries. Look forward to many more productive years in the future. Next. Finally, the message, a message from Division of Particles and Fields Chairline of American Physical Society. CERN's leadership and close collaboration with the US have been crucial for the advancement of the technology and physics at Hadron Colliders. We will strive to continue the tradition and to work together for our common goals in advancing high energy physics. Best wishes for your next endeavor. Next. This is my last slide. I would like to congratulate CERN once more. So the Confucius said that when we human beings reach at the age of 50, we understand the mandate of heaven. So my personal interpretation is that at age of 50, we understand the right questions that nature wants us to ask. So this is where I feel that particle physics is at the Hadron Collider age of 50. One more click. Some of these questions, right questions, will be addressed by Hilum LLC and beyond. One more click. Long live the Hadron Collider. Thank you very much.
Thank you very much, Young-Kee. I hope you heard the applause in the room. I want really to thank you for this talk, kind talk. Thank you for all the messages coming from our American colleagues, from DOE, from the director of Family Lab and so on. I think it's very good and inspiring and very good for the future. Then thank you very much. I think with the technical problem and so on, I don't want to test if you have one question, but I want to thank you and all the best.